In this video, we're going to talk about quadratic functions. A quadratic function has a graph that looks like a parabola. So we want to talk about the important parts of a parabola, how to find those important parts, and how to make the graph for a parabola. So a quadratic function is a function of the form, and it can actually have two formats. One being f of x or y equals ax squared plus bx plus c. That's called the general form. Or it could be factored. We have f of x or y equals a times x minus h squared plus k. There's a lot of variables there. All of those are going to be represented real numbers. We don't want a to be 0 because we want to have an x squared term. That's what makes it quadratic. That's what makes the graph shape a parabola. Okay, if we strip it down to the most basic parabola or quadratic function, y equals x squared would be the most basic shape. And this one is actually centered at 0, 0. So that's the middle point, and we can choose a few x values around 0 to make this graph. So a couple of numbers smaller on the negative side, and a couple numbers bigger on the positive side. For all the x values we choose here, we're going to plug them in and square them. When I square a number like -2, it's like saying -2 times -2, and that is always going to return us a positive number. So +4 here, +1, +1, +4. And if I graph those points, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. I'm going to see that bowl, that parabola shape. So it looks like a bowl. Okay, so any quadratic function may not be the basic one, but it's going to have a shape that is a parabola. So there are some important features of this graph. I want to kind of point those out to you if I can. The first one is called the Axis of Symmetry. The Axis of Symmetry is the line dividing the parabola in half. So if I were to slice this parabola into two equal parts, this shape, this basic parabola, is symmetric over the y-axis. That won't be the case for every parabola, but for the basic one that's centered here at 0, 0, it's true. And so the line, the vertical line that goes through 0, 0 would be the line x equals 0. And this would be the equation of the line of symmetry for this graph, or the axis of symmetry. The next key part of the parabola is called the vertex. The vertex is either the maximum or minimum point. And so for this particular example, we have a minimum point at the point 0, 0. You can see it right here at the bottom of that bowl shape. That would be our vertex. In general, I'm going to pull it up to the equation so you can see that. Let's do this. In that vertex form, The vertex is actually the point where we have the coordinates h and k. So h comma k is the vertex. We're going to talk some more about how to find the vertex, but that vertex form, and that's sort of built around the vertex. That's what makes it so useful. And so as far as what each part of this equation, how they affect the graph, the h is the shift left and right, so it's the x value of the vertex. The k is the shift up or down, and so it's the y value of the vertex. There's two more things we can say about the graph for a parabola, and they're both based on the a that you see in both formulas here. It's the same a, the same variable. If we were to write an equation for the same parabola in both formats, the a would be the same. One thing that the a takes care of is the orientation. If that number for a is positive or greater than 0, then we're going to see that the parabola opens up. And when that happens, when the parabola opens up, like the basic one we just drew, the vertex then becomes the minimum point. It's the lowest point on the parabola. If that number for a is negative or less than 0, then the parabola opens down. We've taken the parabola shape and reflected it over the x-axis. So now the vertex becomes a maximum point. A can do two things. It can talk about the orientation, and it can also affect the shape. So if the number part of A is bigger than 1, then we're going to see the parabola is vertically stretched. Or you could say if the parabola shape is more narrow because it's been stretched vertically. So you have maybe a taller, skinnier parabola shape when we compare it to that basic one that we just drew. If the number part of A, and the absolute value here is allowing us to sort of disregard the sign. We've already addressed the sign up here when we talked about orientation. Now we're just talking about the actual number. So the actual number part of A, if it's smaller than 1, actually that would be between 0 and 1, then our parabola shape is vertically compressed. This is going to give us a wider parabola. So the bowl, it's almost like we've set something heavy on the parabola and it's sort of squashed out the sides. We've squished it vertically and it's become wider. Okay, so that gives you a little bit of a synopsis of what each part of the vertex form, how it plays a part in the shape of the graph. Now we want to go back to the idea of the vertex. The vertex is a very key point for a parabola. There are a lot of applications that we can do with the vertex when we have a function that is a quadratic. So being able to identify the vertex becomes very important. So I want to take a minute to show you how to find the vertex. And since we've mentioned two formats for a quadratic function, we want to be able to find the vertex for both of those. So we're going to do them one by one. I'm starting here with the vertex form. This is the easiest, so I thought we'd start there. This one's already factored, and so we've said that the h and the k, which are actually the shifts or the translations here, they are forming the point that is the vertex. So there's no solving to do here. We just have to pick out the values for h and the values for k. Let me give you a couple examples. Let's say we have an equation that looks like this. So we could take this equation and compare it with the vertex form and pick out the value for h and the value for k. As it turns out, k is actually easier to identify. So what is the value for k? It's 3. K is as is. Just like the vertical shift is as is. If I see something positive, it goes up. If I see something negative, it goes down. So the k is exactly what we see. The h is the shift left or right. And there is a minus built into this formula. So we're sort of disregarding this minus and taking just the value of h. So even though we see an x minus 4, the h is just the 4 part. Okay, and so the vertex is the point 4, 3. The idea behind this h having opposite sign of what we see. Remember, if it's a minus 4, it's shifted to the right by 4. And so that's happening here with the vertex. I'm shifting, I would normally be starting at 0, 0, but I'm shifting it to the right by 4, and that's giving me a positive 4 for my x value. Okay, here's another example. We could do the same thing here. We're just identifying h and k. Let's do the k first again. K is exactly what we see. We see a minus 6. That's our k. H is going to look opposite from what we see. If you wanted to write this in with that double negative, you could do that here. This is like x minus negative 10 squared. And so the h that we see, right, it's in the format just like the vertex form at the top here, x minus some number. What I'm subtracting when I add, that sounds weird, when I'm subtracting a negative 10. By subtracting a negative, it's the same as adding a positive, right? And so I'm rewriting it in a way that matches up with the format. So the h is actually a negative 10. And the vertex for this parabola, if we were to draw the graph, would be at negative 10, negative 6. Think back to the transformations. That x plus 10 would indicate a shift to the left. Starting with the basic graph at 0, 0, moving to the left by 10 would cause me to move over to negative 10. And then down by 6. Okay, so this is how we find the vertex with the vertex form. We just have to pick out the values for h and k, keeping in mind that the value for h is going to look a little bit opposite of what we see in the equation. Okay, what about finding the vertex when we have an equation that's in general form? When it's in general form, we don't have the nice h and k to work with, okay? Somebody, and you can see the derivation of this in the book, took this function written in a general form and factored it with the variables and rewrote it in that vertex form. And what it turned out to be, the h turns out to be minus b over 2a. Okay, so we're going to use this. I don't know that this formula has a name. I call it the vertex formula. So we're going to use this to find the x value of the vertex. And then we're going to plug in x to find y. I really should have had plug in x to find y. Now this x and y are the h and k of the vertex. I've just found that it's a lot easier to talk about if I just use x and y versus h and k, even though they technically are the same here. Okay, so here's our function. If you compare it with the general form, what are the A, B, and C we're working with? Keep in mind that any negatives or any signs are attached to the numbers behind them. So A would be 2, B would be -8, and C would be 6. So to find the x value of the vertex, I'm going to take the opposite of B, so the opposite of -8, over 2 times A. You know what, I wrote this negative out front of the fraction, and that's totally fine. That's not generally how I do it, which is kind of interesting. I'm not sure why I did that. I usually put it in the numerator, okay? And it doesn't matter whether you put it in the numerator or out front. You could even put it in the denominator if you wanted, as long as it's in one place. I'm going to work mine in the numerator. I'll have to make an adjustment to this for the next time. So this is going to give me +8 over 4, which is 2. So the x value of my vertex is 2. Now I need to find the y value. To find the y value, I'm going to just plug into this equation that I have. In the derivation of this, where they found the -b over 2a, there is another formula you can use for the k or the y value. I just like to plug it in here. I think that's a lot easier for us to remember. Okay, so my x is 2, so everywhere where there's an x, I'm going to put in a 2. And then I want to calculate what this is. You could definitely use your calculator. I'm lazy, I don't want to get my calculator, so I'm just going to do it in my head. This will be 8 minus 16 plus 6. So that would be -8 plus 6. So -2. So the x value is 2. The y value is -2. So if we put that together to make the vertex is the point 2, -2. Okay, so anytime we're talking about some function that's written in general form, we're going to use this -b over 2a to find the vertex. Now that we've talked about how to find the vertex, let's integrate this in finding or making the graph. So I'm actually going to take this same example, and now we want to graph this function. Okay, so when I make the graph for a parabola, the first step is to find the vertex, because that's really the key point in your graph, is that vertex. It's right in the center. It's where you can build your t-chart around. So we just did this. This is the same function. Okay, so I'm just going to copy this down. We found that the vertex was 2, -2. We just did all the work for that. If we hadn't, we would do that now. And then I'm going to take the vertex and put it right in the center of my t-chart. And I'm going to choose x values around +2. A couple numbers smaller, a couple numbers larger. And then I can take these values and plug them into the equation that I'm given. If I plug in 0, this is going to be 0, this is going to be 0, plus 6. So I'm going to get 6. You could definitely write this out. I'm going to leave that to you to do on your own. You can stop this video and do that now. Plug all these in one by one, or use your calculator. If I plugged in 1, 1 squared is 1, so this is going to be 2 minus 8, that's -6, plus 6 would be 0. A parabola is symmetric around the vertex. So around this center point, I'm actually going to have the same y values on either side. So if I were to plug in 3, try this out. If I plugged in 3, I should also get 0. Because at opposite sides of the vertex, I have the same y values. If I were to plug in 4, try it out, I'm going to get 6. So let's plot these. You know what? I don't think my grid is big enough. We'll just add a tick mark up here. So we're at 0, 6, 1, 0, 2, negative 2, 3, 0, and 4, 6. And notice the value for A here is a positive 2. So my graph has been vertically stretched. That's why my parabola is looking so tall. And there it is. This is the best way I've found to graph a parabola. Find the vertex, put the vertex in the center, choose x values on either side of that point so you're able to get the whole bowl shape, not just half of it, but the whole turning point and every part of that bowl. Okay, I want to add to this an applied problem. This is one that has to do with projectile motion. This is a common type of problem to look at when we're talking about quadratic functions. This one says, if a ball is thrown upward from the top of a building so that its height in meters after t seconds is given by this formula, the questions we would like to answer are, when will the ball reach a maximum height, and what is the maximum height? Okay, now I don't have to make a detailed graph of this function, but I could make kind of a general one just to give myself an idea of what's happening. In this function, t is acting like the x value, and h, the height, is acting like the y value. So I have a t squared. Anytime I have a variable, or my what do you call x, the independent variable, if it's squared, whatever letter I'm using to represent it, that indicates that I'm going to have a shape that's a parabola. So what about this parabola? Is it going to open up or open down? It's going to open down because the value for A is negative. So I have a parabola that opens down. Okay, and I always like to emphasize this because the ball itself may or may not be traveling in a path that looks like this, but as time progresses, the height of the ball is going up. I'm at the top of the building and I throw my ball up, it's gaining height, and then it reaches a maximum height and gravity takes over, and then as time goes on, the height is going down. The ball is falling to the ground. Okay, maybe it goes straight up and straight down. Maybe it does travel in this sort of trajectory path. We don't know. Okay, either way, it's definitely for sure that this is the place where I'm going to find the maximum height. So in this case, the vertex is a maximum. It's definitely because the parabola is opening down. And the coordinates of that vertex, t is the time, is going to be in the x value, and h, the height, is going to be the y value. So I can use what I know about the vertex to answer these questions. When will the ball reach a maximum height? This word when is asking about the time. And the time is the x value. So I can use the minus b over 2a to find the value for the x part of the vertex. So b here is 39.2. So I can take the opposite of that over 2 times a is negative 9.8. I put that into my calculator. I'll let you do that on your own. I think this comes out to 2. And this is the time in seconds. So this is 2 seconds. So after I throw the ball, 2 seconds later, the ball reaches a maximum height. What is that maximum height? Now I can plug 2 into my formula to find the maximum height. If you put this into your formula, you'll see that it comes out to 69.2 meters.
You're home.